forgotten in the past. There we go. All right. So we are recording, and I will turn it over to our speaker, who's Dr. Norb Psuty. He's from Rutgers University, a coastal geomorphologist and Professor Emeritus at Rutgers, and also is part of the Jacques Cousteau Reserve staff as well. And he's going to be talking about sea level rise on the coast of the New Jersey shore, drivers for coastal change and resilience. So thank you, Norb, for being our speaker today, and I will turn it over to you.
Good. Okay, thank you, Caitlin. As Caitlin indicated, I've been doing work in coastal New Jersey for quite a few years. I arrived at Rutgers about 50 years ago and became interested in the coastal zone and have been sort of collecting data, collecting observations, getting information, working with NJDEP, a number of the coastal communities, a number of the parks along the coast, and essentially sharing information about the kind of changes that are going on, the dimensions of the change, the directions of the change, and trying to provide, I'll call it a scientific basis for decision-making along our coast. And so we're going to basically look at one of the major issues along the coast, and that is the impacts or the conditions of rising sea and the impacts of rising sea as driver for coastal change and coastal resilience. Resilience is kind of the ability to adapt, and there are opportunities for that. What's happening? Okay. The goals, as I've just indicated, are basically the appreciation of the things that are happening, the appreciation of the major drivers that are causing changes. And then I'm going to apply this to a few areas, some general areas and also some local areas, so that we sort of see what is happening. What does it look like when the impacts of sea level rise are occurring? And then the question would be, okay, and then what might we do? How might we respond to these conditions? Initially, we appreciate the fact that there is a primary coastal system as represented in this particular figure. And basically, it is the contact between the land and the water. Usually, if there is adequate material, there is an opportunity for a dune to form, a coastal dune. And this is more or less the location where vegetation is able to come from the continent and stabilize the loose sand. And so dunes tend to be locations of the contact between the marine influence and the continental influence. Then usually there are some vines or runners going out from the dune vegetation and trying to secure some of the beach, whereas the waves and currents along the beach are tending to mobilize the sand and keep it sort of free of vegetation. So we normally have, I call it a three-part primary coastal system: the dune feature, which is a kind of stabilization of sand; the bare sand beach, which is a very mobile area; and then there's the offshore zone. The offshore zone are essentially where sediment is being maintained. Sediment occurs there, sediment is transported there, and it is interacting with the waves and currents. So we have these kinds of environmental systems that are present. We call it the sand sharing system, and we see that there is a combination of processes such as waves and currents and wind interacting with material, essentially sand, and that provides us with the kinds of responses. We talk about seasonal changes, winter versus summer, or high energy versus low energy. Winter times, storms, high energy, the interaction takes place high on the beach, sometimes into the dune. So some of the dune face may be mobilized and sediment being transported to the offshore. And usually that material accumulates in the form of some kind of longshore feature, longshore bar, longshore accumulation of sand. And that's the result of the high energy level that is taking the material and transporting it both alongshore and offshore. If it collects offshore, there's the opportunity during the lower wave energy conditions, the summertime, to essentially transport that material from the offshore back to the beach. And so that becomes a kind of cycle, that there is the offshore transport and during the high energy, and then there is the onshore transport during low energy. And if these things are balanced, as much material returns during the summertime as leaves during the wintertime, essentially we have an equilibrium sediment budget. But if it is more material going offshore than coming back, then that's a negative sediment budget. And there tends to be a shift of the profile inland. And if there is a positive sediment budget, then basically the features begin to migrate offshore. So sediment budget is important in terms of, is the feature, is the sand sharing system, is it migrating inland? Is it migrating seaward? Or is it more or less staying in place? So sediment budget is a very important measure or metric of what is happening at the coast under the variety of processes, waves and currents, and also the process associated with sea level rise. So coastal processes produce a form, the beach versus the dune versus the offshore. Sediment budget produces some variation through time, that's through seasons, and some variation in terms of the location, that it's either moving seaward or landward. And then sea level change or sea level rise, as you can appreciate, will actually take this form and push it inland. And so sea level rise is another component as a driver that's causing the feature to move, to essentially shift. Now we're going to sort of look at coastal New Jersey and kind of characterize what we find there. And eventually we'll get back to, okay, how does it interact with sea level rise, and sediment budget? Basically, our coast, as you can see, is made up of a variety of features along the coast. I refer to this as coastal diversity. That is, it isn't just one kind of thing here. There's quite a variety of features of landforms along our coast. At the very northern end of our shoreline, we have Sandy Hook. And Sandy Hook is a kind of spit that is a result of material sediment being transported primarily northerly and going into Raritan Bay. And then, if you notice right opposite where the term coastal diversity is positioned, that it is the continent that's coming right down to the coast. It is the land that is part of the continent that is right at the coast, and we have a cliff coast in that location. Basically, there is a cliff maybe on the order of 10, 12, up to 20 feet high, which is lining that portion of our coast, mostly Monmouth County. And then below that, we have two long, we call them barrier islands, two long extensions that are going southerly from the coast, the cliff coast, extending down to Barnegat Bay, and then another very, very long barrier island, the Long Beach Island, and that's extending down to Mullica. And then beyond that, or south of that, a series of smaller, shorter barrier islands, which have a little kind of unique characteristic. And that is, they tend to have a larger, higher, northerly component, a narrow, lower, southerly component, and we geomorphologists use some terminology now. We call those drumstick barrier islands, meaning that they're fatter on one end and skinnier on the other end. And they are indications of the fact that the sediment transport goes from the fatter end to the skinny end. And for us, that means that the transport is from north to south along those shorter barrier islands. And then another thing you'll notice is that there's a bay or estuary between the barrier island and the mainland. And at times there is marsh growth. You can see sort of the reddish coloration. There is more marsh in the central portion of our state. There is some in the southern portion of our state, but it is not completely filled in. And so there's a lot of open water along the coast of New Jersey between the barrier islands and the mainland. What is important for our development along the coast is that there is no new source of sand coming into our coastal zone. So our sediment budget, for the most part, is negative. If you look at the major rivers that are coming toward the coast, whether it's the Delaware River or the Mullick River or the Barrington River, they are not leading to deltas. They're not leading to areas of sediment accumulation. They're coming into open bays. And so there isn't enough sediment to sort of fill the bay. And that means there's not much sediment getting to the coast. For the most part, that says we have a certain amount of sand available. It might be locally redistributed, but it's not going to be replaced. No new material. But there is considerable human manipulation. There are places where sediment is being transported into the coast by beach fill. There are places where sediment is being removed and eroded, essentially because of dredging. There are places where sediment is being stabilized by artificial placement of covers or houses or roads or whatever, but there's just a lot of manipulation. What has happened along our coast is essentially the end product of a very important component of geological change along our coast. You're probably familiar with the fact that there has been glaciation, major cold spells in our world. And this has happened several times in which we've had ice and snow accumulate on the continents. And that snow and ice are basically the result of water being taken from the world's ocean, the cold and the snow accumulating on the land surface, which essentially reduces the amount of water in the ocean, and the ocean level drops. When there's a lot of ice stored, there is a very low level of or there is a great amount of reduction of the world's ocean level. The last major glaciation along our world took place around 20,000 years ago. That's a long time, but in geological time, that's relatively short. The amount of ice and snow accumulated to the point that the world's ocean dropped by about 400 feet, somewhere on the order of 120 to 150 meters. That meant that the shoreline was way far seaward of where it is now, over 100 miles farther seaward than what we see at the present time. It was all on the continental shelf. And they basically 20,000 years ago was the time when it was about the farthest away along the continental shelf. And then since about that time, there has been some increased melting of that major ice. And so that there has been a return of the water to the world's ocean, and sea level was rising. It didn't come up all at once. It came up fits and starts, sometimes a little faster, sometimes a little slower, some kinds of reverses. But for all intents and purposes, most of that 120 to 150 meters of shoreline, of ocean lowering was recovered by about 5,000 years ago. 5,000 years ago, sea level was only about 7 meters, or about a little over 21 feet lower than at present. And that meant that most of that rise had occurred, and it occurred quickly. It was a flooding of our offshore zone, a flooding of the whatever was exposed. And we try to look for evidence of what did it look like. And there are a few places where we can get some data, but for the most part, it was a kind of transition zone. The water was coming up. It was manipulating whatever it was encountering, shifting it around, pushing it seaward, pushing it alongshore, pushing it inland, and basically flooding our coastal zone. And so that's somewhere on the order of about 5,000 years ago. Sea level was on the order of 7 meters below the present, and it was slowly rising, but still not really showing a lot of on-site accumulation, that there weren't features and forms that we can point to and say, oh, look, here is where material was accumulating. That wasn't happening. We don't see much evidence of that. And it wasn't until about 2,500 years ago, again, relatively short time in terms of geological context, but again, it's the last couple thousand years here. And now we began to see the sea level rise was sufficiently slow that there were zones of accumulation. The sediment that was being encroached upon, the sediment that was being overrun, the sediment that was being covered by the slowly rising sea was essentially amassing and creating the barrier islands, creating the expansion of the barrier islands. Now our barrier islands weren't shifting so much. Now they're more or less accumulating in place. Now we talk about the fact there was a kind of ecosystem equilibration, that the features themselves were more or less on site and not really moving very much. So for a couple thousand years, we more or less were saying, all right, look, the barrier islands, they were on site, they were expanding a bit, they're getting a bit higher, a bit wider. The adjacent marshes were accumulating, the wetlands were expanding. And so that's relatively recent, relatively new in our coastal zone. And much of our coastal zone would look very similar during this period of time. Then a couple hundred years ago, we began to see evidence of sea level rise beginning to increase in rate. That this coincided with some of the changes that were taking place along the world's coasts. The forests were being cut down. Vegetation was being sacrificed in order to build ships. Vegetation was being sacrificed in order to build farms. There was the agricultural revolution. There was the sailing revolution. And then more recently, there was the industrial revolution. All these things were sort of changing the atmosphere. Some of this was causing more dust in the atmosphere. Some of it was causing different levels of ozone in the atmosphere, and was reducing the combination of the atmosphere, but leading to an increase in temperature. And the result was sea level began to rise again at an increasing rate. And we began to see from a couple hundred years ago that the barrier islands were showing evidence of erosion. The barrier islands were showing evidence of a narrowing. The ecological system was being changed. It wasn't quite as static anymore. There were changes taking place in terms of the distributions. There were changes taking place in terms of the quantities. The wetlands began to decrease in terms of their extent. And so changes were taking place in our coastal zone, and they tended to coincide with the fact that the atmosphere was changing, the temperature was changing. So we now see that there's a kind of I'll call it a context that what we see at the coast is undergoing initially changes from very rapid rises of sea level, then to slow rise of sea level, and now a kind of return to a rapid rise and a kind of return to a disequilibrium. And that's where we find ourselves now, in this kind of disequilibrium. And so we began to look at our features, our barrier islands, our barrier island features, and sort of look at in terms of what does it look like and how is it changing? And this is an example we have of a place from the southern margin of the continent exposure, where we have a cliff coast and leading to the long, narrow barrier islands. And we see a lot of the Seaside Heights area. We see Island Beach State Park in this particular portion of the long barrier island. And we find that the features themselves are now undergoing the changes that are the result of less sediment being available now, less sediment in the offshore, and now we have a negative sediment budget to work with, a slowing of the amount of material, a loss of the material. And then we have, in addition to this, we have this increased rise of sea level. All these are drivers that are sort of saying, okay, look, the system is going to change. The system is undergoing a kind of migration, a kind of evolution. And let's kind of look at, okay, what is it? How is it changing? What are some of the characteristics? We start with trying to understand what are the rates of sea level rise. Okay, this is from the tide gauge at Atlantic City. Tide gauge started around 1911. This data here go to about 2020. And we see that there's a general plot. The blue line is essentially a monthly mean elevation. And we see the changes taking place, monthly mean elevations reported on this tide gauge. And we see this change through time. Interestingly, when I first came to Rutgers around 1970, I had a friend who said, oh, look, I think it's kind of interesting when we see the Atlantic City tide gauge at the time, and it's saying that sea level is rising. What do you think? And can you see any evidence? So I began to look at the tide gauges. I began to say, oh, look, I can see that there is a trend of sea level, and this red line is telling us the general trend, and the rate was on the order of 4 millimeters per year. And so that basically is saying, okay, through time, that's the rate of flooding of our coastal zone. Yeah, there's a lot of variation, and there are stormy periods and less stormy periods, but there is a general trend, and that's taking place. And interestingly, we talk about relative sea level. It's the water coming up, but also the land going down. The eastern seaboard of North America is essentially a subsiding portion of the continent. The continent is undergoing elevation on its west coast and subsidence on its east coast. And so there is a kind of depression of the eastern side of North America and of the United States and New Jersey. And in addition, a lot of the recent material, now the recent sands, the recent marsh material, the recent sediment that has been deposited as a result of a sea level rise, that is undergoing some compaction of its own weight, compaction of the sediment that is now being covered by water, which has weight. And so we have sea level coming up, the water coming up. We have the continent going down, and the sediments, which are accumulating along this continental margin, compacting as a result of its own weight. So relative sea level consists of those three things: the sea level rise, the subsidence of the continental margin, and the compaction of the loose material. That's the rate that's taking place. However, we can look at these same data, and instead of looking just for the linear trend, we can do some statistical manipulation and say, is the rate of sea level rise changing? Is it increasing? And if we look at that in terms of exponential rate, okay, excuse me a minute, I'm just have to mute for a moment. Okay, back again. All right, statistically, we can look at these same data to see whether or not there is a change in the rate of sea level rise. And we do this and we say, okay, let's look at the red line says there's a really good fit of the data around that trend, and refer to R squared, or it's a combination of it's a measure of the change around the line, and the exponential trend, which is saying, look, this is an increasing rate, and the R squared, which is the measure of the coincidence, says it's about the same. That the rate can be increasing. Now it's not 4 millimeters per year. It could be 6 millimeters, 8 millimeters. It's different. It's higher, and it looks like it's an increasing rate. So increasing rate is going to cause changes to occur much more quickly. All right, so now we have the same data from Atlantic City saying, okay, change is occurring, and they're going to occur at an increasing rate. Interestingly, the data from Atlantic City and from Sandy Hook are almost identical. That is, they have a similar kind of rate, linear rate of approximately 4 millimeters per year, but an exponential rate of at least 6 to 7 to 8 millimeters per year. So they're saying our coast is undergoing this change, and it seems to be relatively consistent up and down, even up and down our coast. And what does it do? What does it look like? How does our system respond? Remember, we talked about before about our sand sharing system, and we talked about the dune, the beach, and the offshore. And what we see in places are evidence of this inland migration of the system, the sand sharing system. This is the place where we have a nice coastal dune, and we see a lot of new sand that's being accumulated along the inland margin of the dune. The dune feature is kind of shifting. So now there's not as much vegetation on the seaward side. There's more vegetation on the landward side. There's still vegetation, but it looks as though it is responding to the fact that sand is being shifted inland, is being blown inland, is being transported by storm waves inland, and the dune feature is migrating inland. So it's accumulating, maybe retaining its similar kind of dimensions, its similar quantity of sand in the dune form. It may be the same kind of elevation, the same general width, but it's being displaced. Now we refer to that as system resilience. That is, it is maintaining the sand sharing system. It's retaining much of the dimensions of the system, but it's just in a different location. It's migrating. It's being driven by the fact that we have a negative sediment budget and being driven by sea level rise, both of these causing a general migration of the features. Well, what about this? This is actually not too far away from the previous shot, and we talk about this one. Is this resilience? Is this evidence of the landform adapting to it? And the answer seems to be not quite, because now we don't see the same kind of evidence of the sand being transported across the crest and building the backside of a dune. We see a lot of erosion along the seaward margin. We don't see the same kind of vegetation along the seaward margin as we saw before. We don't see much in the way of any kind of stabilization. What we see is evidence of sand fences to try to put there, try to stabilize some of the sand, stabilize the form, not being very successful. This house, by the way, and we do have some evidence of it from earlier photographs, saying that there used to be a dune on the seaward side of this house. The house used to overlook a dune crest and extend looking seaward. The dune crest is moving inland of the house. By the way, this house has been shifted and is no longer there, but this is evidence of the fact that resilience is not being as capable of maintaining everything here. The dune feature is losing some mass. The dune feature is losing some of its cross-section area. The dune feature is losing some of its dune sand. And so there is a reduction in the ecological system, reduction in terms of the barrier that's there. So this is good evidence of the fact that there is a kind of loss that is taking place, driven by the negative sediment budget, driven by sea level rise. So resilience, not quite so prominent in this area. Remember what we had before with our dune beach system and sharing the certain processes, sediment budget profiles. But we find that in many places, because of the negative sediment budget and inland displacement, that the feature, the dune form, the beach form, as is migrating inland, is migrating over old marsh deposits. The marsh is being covered by the migrating sand. That's a migrating of the sand wedge, migrating of the dune form, migrating of some of the beach sands. And evidence of this is the result, as can be seen in terms of portions of the beach being locations of outcrops of the marsh peat, the marsh being covered and then being exposed. And so if we see places like this, here's a marsh layer that's outcropping in the beach. The beach sand is moving upwards and across the marsh. The dune is moving upwards and across the marsh, but the marsh is being exposed. And that's good indication of the fact that this is happening. And we can actually date the marsh, the organics in the marsh. We can say, oh, this marsh is 500 years old. 500 years ago, it was inland of the dune. Now it is seaward of the dune. And we can find this over and over again. We find this very often along the bay margins of our bays, of our barrier islands. They tend to be locations where marshes are being exposed because of this migration of the dune form and the beach form. People who have studied sandy beaches around the world more or less have said that 90% of the world's sand beaches are eroding. That is, we're talking about barrier island systems, areas where there had been accumulation of sand, beaches, dunes, offshore zones, that most of these beaches are losing material. Most of these areas are negative sediment budget. Most of these areas are being affected by sea level rise. And we find that worldwide, there are attempts to try to stabilize these shorelines. Worldwide, there are attempts to repair the changes. Worldwide, there are attempts to manage some of the modifications that are taking place. And again, we can see this is a national problem, a worldwide problem, a local problem. All these places are being affected by the combination of negative sediment budget and sea level rise. And here's a great example of this. This is Long Beach Island, coastal New Jersey. And we can see toward the top of the slide here, a lot of the development that takes place along this portion of the island. Most of it is essentially completely covered with development. We can see kind of stepwise change in the location of the housing. That's more or less periods of time. The seaward most are the oldest areas, and then the area to the base of the photograph is essentially a wildlife refuge. It's allowing the natural system to function, and it's functioning by maintaining its ecological areas. It's maintaining the beach, it's maintaining the dunes, it's maintaining the marsh at the inland margin, but is also migrating inland. It is being displaced and it's shifting, and it's shifting by sediment being transported across the island from the beach through the dunes to the back marsh. That's kind of the migration. That's the response to increased sediment, increased sea level rise, and decreased sediment supply. And if we sort of just look along the location of this shoreline that on the ocean side, it almost lines up with the shoreline on the bay side of the developed portions of the island. In other words, this portion of the island has migrated inland approximately the width of the barrier island. It is still retaining itself, still retaining a lot of the character, but it is not in the same place, not in the same location. It has shifted naturally by transporting material across the island. Here's the way it happens. This is the result of Hurricane Sandy in the end of September 2012, and sediment was being taken and just thrown across the island by the high water level, by the waves, by the currents. You can see a lot of the bare sand as it's being transported across the island, covering the marsh, extending the margin of the island into the adjacent bay. And so this is the way in which the island responds to storm events. It is the displacement, the shifting, the retention of the character of the island, kind of the island resilience, but it's a different location. And this is the recent look from just a few months ago. And it says, look, a lot of the island has stabilized. A lot of the island has recovered. Now the loose sand is now being shifted to the southern portion of the island. Remember I mentioned before, these barrier islands tend to have material going from north to south. So now the barrier island is extending to the south, but it's also extending inland. This island is shifting inland, and it's shifting into the bay, it's shifting into the inlet, and it's the natural migration of the island as a result of its normal sediment transport, its normal sea level rise impact, this normal negative sediment budget. It is a continuation of the island, but just not in the same place. And it's telling us this is the way in which the island will respond. Here's a view. It's a little bit different. This is Island Beach State Park. Nice beach. There's a dune zone. You can see the vegetation, a lot of little holes in the vegetation, sediment, bare sand inland of this first crest, and then the vegetation relatively solid behind that. What we see here is actually the kind of evolution that takes place in an island when there is enough sand to sort of allow resilience to occur. Here is a resilient area. It is continuing to survive. It's continuing to have a variety of features, but just not in the same place all the time. This is the kind of evolution which is taking place as the island is shifting inland, as a dune feature is breaking down, sediment migrating inland, restabilizing an inline position, and essentially reforming. And so here, this is kind of, you can see this is a dynamic zone. Beach, bare sand, some dune vegetation, some bare area, and then vegetation which is stabilizing the sand. So it's a pretty good zone of dynamic evolution, of resilience taking place. And here, comparison, all right? Island Beach State Park, we just saw that. We see the beach sand, we see the mobile zone, but we look at the community to the exact north, and we see that there isn't the same kind of zone available for migration, zone available for resilience, zone available for sediment to be retained, to be stabilized, to maintain portion of the features that are present of the barrier island. All right, so now there is a potential conflict in terms of we can't stabilize, we can't catch as much sand in the dune, in the developed areas. We have too much open area. We have too much location where sand is not going to be caught, where it's not going to be accumulated. And so we're not going to have the same kind of stability, not going to have the same kind of maintenance of the natural system in the communities as we have in the barrier island. So the spatial comparison, I think, is kind of dramatic. There is not as much opportunity for stabilization, not as much opportunity for resilience in the developed communities as there is in the natural area. Here's a good example of a kind of stabilization associated, a kind of mobilization associated with a natural region north of Atlantic City, north of Brigantine. This is an area where we have a large marsh region. There is migration of the beach and dune system here. And if you look carefully along the beach, we see a lot of dark areas exposed. That's peat. That's the old marsh that's being exposed. And so the sand in this area is just the area, the sand material on top of the peat. It's very limited. It means that storminess, winds, waves are going to transport sand here much more quickly than in places where we had a large thickness of sand. And that's the presence of a large part of our barrier islands, that there is sand now on top of marsh deposits. They're going to respond more quickly to storm impacts associated with the high water and negative sediment budget. Another condition that takes place associated with the marsh and resilience is the fact that marsh edges tend to be locations where marshes are being eroded. Sediment being eroded is being transported into areas to accumulate to the inland. So places where you can see the green vegetation, those are locations where sand is still enough in order to maintain the marsh. But large areas, the sand accumulation is not enough. The sediment is being lost. The sediment is being transported inland to other areas. This is the indication of lack of resilience. This is an indication of marsh deterioration and habitat loss. And this is occurring along many of the margins of our barrier islands. Here's potential for disaster. All right, high elevation, high population, low elevation. Storminess is going to just inundate this area. Baysides are especially vulnerable because there's nothing there that's kind of interrupting the flow of water. There's no barrier, there's no beach, there's no dune. This is sunny side, high water. This is just tide. This is high tide flooding the street. At times with extremely high storm times, with high spring king tides as we have now, this street would be impassable. We put a foot of sea level rise, there's no way we're getting around this area. This is an example of the impact of sea level rise. along the left margin, these are elevations associated with storms at the time of their occurrence. And these are in the low, these are in the frequency of 5, 10-year, 20-year storm events. As we add sea level rise, these events become closer to the 50-year events, the 100-year events, the rare events, which are greater flooding because of sea level rise. Common storms are going to produce greater and greater flooding. This is the portent of things to come. How about that? Sustainable development, not likely with sea level rise and negative sediment budget. Not too much future here. So negative sea level budget and sea level rise have been causing changes. They will continue to change because that's not change. They're not varying. It's going to get worse, as a matter of fact. It's the knowledge of the magnitude of the change that are necessary for us to understand what is happening, where it's happening, if we are to make any changes whatsoever. So with that, that's my presentation. I welcome any kind of chats. Caitlin, if you want to sort of take over now, we'll see what has to be done.
Excellent. Well, thank you so much, Norb. That was fantastic information and really great images as well. I did want to share something else kind of in addition to those pictures of what's going on with the sediment and changes over time. For everyone who is interested, if you'd like to check out an interesting tool, I just put it in the chat, it's called Google Time Lapse. It's through Google Earth, and if you click on it, it will probably take you to some maps of Alaska or something that show you, changes in glaciers and things like that, I think from the 1970s, but you can zoom in and out. And if you go to the coast of New Jersey, particularly the area of the Molucca and Barnegat Bay, you can actually see the changes to the barrier islands, and Holgate is also very dramatic too. And I think it goes from 1987 to about 2020. So really, really cool. You can, play with that tool for hours.
That's a great tool. That's a great tool, by the way.
Yeah. So feel free to check that out if you like. And we do have a question in the chat, which I'll relay to you, Norb. It is, what stops Island Beach sand migrating from filling the Barnegat Inlet or filling in Barnegat Inlet? Is it just the jetty?
Well, there is accumulation at the inlet, and there's enough flow through the inlet to sort of maintain the channel. And we had a study a number of years ago to look at the velocities that are through there, and it's sufficient velocity to maintain the channel itself. However, as you go to the inland margin, there is a kind of deltaic form, which is being created at the inland margin of Barnegat Inlet. However, there's not enough sand that ever will fill that portion of the inlet. There will be some places where there'll be more subaerial accumulation, some islands that are sort of increasing a bit. They'll depend upon the rate of sea level rise. The Barnegat Bay will never fill in, and it's likely that there may be some locations up and down that particular barrier island that may breach at times. In fact, there are a lot of old inlets that are buried by the current barrier island. So there have been changes in the past. I see that occurring in the future, but probably not enough material to ever get into Barnegat Bay to completely fill it. It's very unlikely that any of our bays up and down the coast are going to be completely inundated with sediment. It'd be more likely that there are going to be more and more water appearing.
Okay, great. Is that kind of as a follow-up question, is that what happened south of Holgate recently, forming what is being called Horseshoe Island? Yes.
And basically, it's a lot of the sediment kind of, remember, we saw a lot of sand that's going south from Holgate, and it's kind of filling in some areas. So there are some places where some islands are accumulating material, and that's going to be local. There have been in the past islands that existed in that region that were lost because there wasn't enough sand coming in. But basically, there always be some local places the sediments will be accumulated, but the net effect is going to be a maintenance of open areas of channels and a loss of the wetlands and a loss of the beach zones in that region.
All right. Well, thanks so much for those questions. Anything else for Dr. Psuty today? Oh, someone just put in the chat, great presentation. Thanks to all.
Okay.
All right.
Thanks, Caitlin.
Yeah, well, thank you, Norb. And I'll just give you kind of a virtual round of applause for everyone else as well. So thank you so much again for your time today, talking to us about this really, really important topic, very relevant to a lot of us living on the coast. And thank you everybody for participating today. If you have any questions that kind of come up later, feel free to email me and or Norb, and but if you email me, I can pass it along to him. And hopefully we'll see you at the next Lunch and Learn. So thank you everybody. Have a great rest of your day. Thanks, Norb.